Good morning, everybody. I call this one CSI Service Bay. Because a lot of what we do is kind of like detective work. Whenever we're presented with a problem and we've got to sort out the data and analyze that data to figure out what it is that we're that we're needing to do to take care of the problem. Because basically what customers do is they take their problem, they pay us to make it our problem. My dad had this lady that came to his shop one day, and she said, "I'm going to pay you a monthly stipend, and every bit of the work that's ever done is on my car is going to be done by you, and I'm going to have you check my car out every month, and if anything ever goes wrong with my car, it'll be your fault." And my dad told her to just go find somebody else because he wasn't interested in having anything to do with a deal like that. Somebody wants to make it your fault if their car ever breaks down for any reason. That sounds ridiculous. Well, this 1998 F-150 came in with an engine skip. It was a truck that wasn't used very much. It was kind of a farm truck. And it had a P0305 DTC, which was the first thing you pull up. You got a flash and check engine light, and you're looking, and had over 200,000 miles on it at the time. And this one here's got coil packs, not plug. No, it doesn't have coil on plug. It's got coil packs and plug wires, and like they got away from this later on. But basically, the coil packs and the plug wires was what this one had. So we eliminated the obvious. We pulled the spark plug out. We had a look at it. The injector was clicking, the spark was present, the spark plug didn't look greasy. If the spark plug looks greasy, it's either because the spark plug has failed or because something else is causing it not to fire, and it's greasy just because of unburned fuel, wetting it and everything. So we put on our detective hats. All right, had these two guys get started. They came in my office and they put the known facts on the whiteboard, which is basically what I've already shared with you. So I put on my Horatio Kane CSI Service Bay sunglasses. If you've ever watched CSI Miami, you know how this guy talks. And I said, "This is what I want you to do. Get a compression gauge screwed into that hole. Let's see how far the number 5 will push the needle." Ordinarily, when you do a compression test, if you're just wanting to see what the compression is on the whole engine, what you need to do is pull all the plugs, and then when you do each compression, whenever you're checking the compression on each cylinder, you're supposed to open the throttle wide up. You're also supposed to disable the fuel system to keep, from spraying fuel in there and wetting the cylinders and skewing your readings with, making let's see, a wet compression test that you didn't mean to do. All right, so spin the starter at least 6 puffs and let me know what you find. Okay, so it was obvious when they were spinning it over initially that the crank was picking up speed during one of the 8 compression strokes. So I knew it had low compression, and it was probably going to be on number 5. That's not rocket science. You can hear that in the parking lot. Somebody spinning an engine over it going, whoa, 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 like that. One of those cylinders are not squeezing air, and that air is going somewhere. All right, all right, did a compression test. After the 6 puffs, the needle pointed to 70 psi of compression, which was less than a third of what it should have had on any overhead cam engine. Overhead cam engines, particularly if they've got multiple valves, like if there are 4 valves per cylinder, will typically have more compression when they're healthy than a 2-valve engine, a 2-valve, camshaft in a block engine. I always thought it was weird how they would call the ones that had the camshaft in the block overhead valve, and they would call the other ones overhead cam. Well, all the valves are overhead unless you're talking about a flathead engine like a old Briggs & Stratton or the old Ford flatheads they used to have. The valve is always going to be overhead. That's a strange way to put that, I thought. All right, so we found out TDC compression on that stroke. We got to get the TDC compression before we can do a cylinder leakage test. You got to have the piston at the top. You got to have both valves closed. The reason the piston needs to be at the top is if the piston's only part way up. Whenever you put pressure in that hole, even if it's not very much pressure, sometimes that pressure will push the piston down and it will turn the crankshaft and it will open a valve. So you basically need it on top dead center compression on the cylinder you're going to check. Well, that sounds good, but how are you going to find top dead cylinder compression on a cylinder that's not marked? Now, if you've got, excuse me, I'm sorry, if you've got timing marks on your timing cover and on your balancer, you can basically, and let's say if it's the opposite cylinder, if it's the companion cylinder on that engine to cylinder number 1, you can line the timing marks up. But if it's not, then you're going to have to figure out another way to find top dead center on the cylinder you're wanting to do a cylinder leakage test on. And these cylinder leakage testers, you can buy these on Amazon and everywhere else. They're real easy to come by, and they're not hard to use. What you're supposed to do before you connect your hose to it, you hook your air hose to the feed inside, but you don't hook up your compression. And this knob right here, you turn this knob with the hose disconnected until this reads 0. In other words, this needle will be over here is where it'll be. So whenever you turn that knob and you dial this, don't pay attention to that gauge. It's not even there. It doesn't even serve any purpose here. But that right there is going to tell you your cylinder leakage. So you're going to dial it in so that whenever there's not any leakage at all, it's going to see 0. Then when you put it in your cylinder, this needle will indicate how much cylinder leakage you have as far as a percentage. Alright, now I have this little kit made by Innovative Products of America that's got all the stuff in it you see right here. As a matter of fact, this is my kit that I took a picture of. And the old part number for this kit used to be 7891 for IPA tools. You can look that up. They don't make this entire kit available anymore. And if you look on their website, you can't find any part of this kit except maybe the whistle part of it. However, this part right here, well, actually it's like this one right here. I think it is from what I've seen. This one here is available by itself for $25 on Amazon, made by this same company. And it's really handy. Now you got to be careful when you're using these things to make sure that the spark plug hole is looking right down onto the top of the piston, because if the piston is coming up at an angle to the spark plug hole and you've got this thing in there, you're subject to bend the tool and mess it up. So this is only good if you're looking, if the spark plug hole is almost either right on top of the piston, straight down, you know, like it's perpendicular to it, or if it's almost perpendicular to it, you can use this, but you got to go really slow and be really careful. And I'd put some grease on the tip of this darn thing too. I like to do that. Well, anyway, so there's also, you can buy another one that's got, I actually had my students build TDC finders for old camshaft and the block engines that it doesn't matter if you turn them backwards or not. And so what I would have them do is get the spark plug shell, bust all the ceramic out of it, and get a piece of 3/8 all thread about 5-6 inches long, and use a tap to tap the center of that spark plug shell out, and then you've got you a cylinder finder. You go back and forth and mark in each place where the piston makes contact, and then you'll halfway between the two marks you made out. That's a whole other lesson, but anyway, you can do that too. That's not a good idea on any engine that's got a timing belt or one of these newer timing chains in it, because turning the engine backwards is flirting with disaster, because you can cause it to jump time and cause all kinds of other problems turning the engine backwards. So try not to turn the engine backwards if you can help it, unless it's an old 350 or 302 camshaft in the block thing or whatever. Alright, so using this whistle, we brought it up to coming up on top dead center is about as good as you can do on that, because what I've also had my students do is stuff a cork in the spark plug hole, or just pack a rag in there and, you know, bump the engine till it pops the rag out. Of course, if there's no compression at all on the cylinder, it's not going to do that. And we were looking for top dead center. Now you can find top dead center on the companion to that cylinder if you know the firing order, and that's one good way to do that. But top dead center on the other cylinder is going to be, it's going to be on exhaust. So what you got to do when you find top dead center compression on the other cylinder is turn the crank the number of degrees required between firing events. Like on a 4-cylinder, there's 180 degrees between firing events. So let's say on a 4-cylinder you found the top dead center compression on number 4 when you needed to be top dead center compression on number 1. Once you find it on number 4 and you know that you're on number 4, you can turn it 180 degrees. Of course, like I say, your timing marks would help too, but on 2 and 3, all right, now on a V6, it's 120 degrees. You didn't need to turn it. And then on a V8, it's 90 degrees. So basically, one of the things that you need to recognize is knowing the nuances of that. You can use your own method to find top dead center compression on the cylinder that you're working on. Now this one here, this is shown on a 2.2 liter Toyota. You can see how this fancy little spring-loaded thing was sitting on top of the piston. Whenever you're barring the engine over, you could very easily find top dead center with this thing. Because as soon as this thing stops going up, you're at top dead center. Alright, and so we went ahead and made sure that we were at top dead center on cylinder number 5. Alright, and we had 70% of cylinder leakage. It should have been a lot less than that. Now we had 2 rock solid data points, 3 if you count the dielectric trouble code. 70 psi of compression, 68% leakage, which was about 70% leakage, and we had the PO305. Now we needed to see where that air was going. Alright, so we did a smoke test. I says, which, you know, most people wouldn't think of doing a smoke test here, but I said, let's pump some smoke into that hose. We disconnected the cylinder leakage tester hose and we used the smoke machine to start generating some smoke, and we pumped a bunch of smoke into that cylinder, and lo and behold, it's coming out the intake. Now remember, both valves are supposed to be closed, so, you know, a lot of the times you can take, if you got a really, use your stethoscope, pull the end off of use for a listening pipe, you can, when you're got your air going into your, through your cylinder leakage tester, you can listen in the intake, you can listen in the crankcase, you can listen in the exhaust. And if it's leaking in any of those places, you'll hear that air hissing in there, you know. Alright, so this was making its exit through the intake manifolds. I said, well, that's going to be an intake valve, so what that's going to be. Well, what should we recommend here? We need to consider the cost of whatever we need to do. This is a 200,000 mile farm truck. And so do we need to spend a lot of time and money doing an engine overhaul on this thing? And incidentally, most shops nowadays don't do a lot of internal engine work anymore. Now, a lot of shops still do, but the ones that I know about, the successful shops that get a lot of work moved through there, what they do is they go ahead and get a Jasper engine or something like that, because that way whoever the engine rebuilder was is covering the warranty on the engine, and if they rebuild it, then they've got to warranty that engine, and if the engine comes back with some kind of a problem where they got to tear it back down, they're doing all that for free. So the safest way to go about it is to get an engine from LKQ, or to get a Jasper rebuilt engine from, or you can buy rebuilt engines from the parts store, you know, if you want to get off the money. Or you can buy crate engines from the dealer. Well, anyway, we decided we're going to try to do the cheapest, quickest way on this one here. Now, what you got to realize on these 4.6s, and a lot of people don't know this, even if you look it up online, the 8th digit code, and this is crazy why Ford did this, Windsor, the 8th digit is a 6. That's the engine code and the VIN number. On a Romeo, it's a W. Why didn't they make the Windsor a W and the Romeo a 6? I don't know. This is the dumbest thing I've seen. Now, the engines look almost just alike, but there's some subtle differences. Notice on the Windsor and on the Romeo, the cylinder head looks different. The Romeo has a different timing chain guide set up. The Windsor has more valve cover bolts than the Romeo. The Windsor uses a dowel on the main bearing caps. So just because you got a 4.6 doesn't mean you're going to have the same 4.6 in your truck that your buddy has in his truck of the same year model. If you look at that 8th digit on that serial number, that's the key in getting the right parts for this. Even buying something as simple as valve cover gaskets. You can go and buy valve cover gaskets for a 4.6. And if you don't know which one of these engines you have, you're going to get the wrong gasket, because the valve cover gaskets are not interchangeable. And you can see the difference in the way the heads look. Alright, if the intake valve had been totally open, 100% leakage, totally burned, maybe bent or whatever, some exploratory surgery might have been ordered to check for a broken valve spring or something simple we could do without tearing the engine all the way down. But this head would seem to be a candidate for a valve job, and that's a pricey repair on a 200,000 mile 4.6. time and chain kits, gaskets, and everything would put this repair estimate really high. The used engine might be in order if they weren't planning to use the truck for another 20 years. So I called LKQ and they priced me a power plant for $650. You can buy an overhaul kit though online from Amazon. This is where I got this one. I found it on Amazon for like $600, and they will send you all of this stuff you see here, which you're seeing: bearings and oil pump, timing chains, rings, pistons, all that for like $600. Now you still have to tear the thing down and go through it, so go figure. Anyway, we decided to pop an engine in it because that's the quickest way to do it. Time is of the essence too. Well, 2 other jobs came in. We had put the radiator and repaired the AC on this 2003 Chrysler 300, but now it was getting hot again. It turned out it needed a water pump. And so I had one of my students put a timing belt and a water pump on it. You can see right there over here where I showed the water pump had been leaking and all. Well, there was a hot PT Cruiser that wouldn't pull to the right. You might have remember me telling my neighbor across the road, I saw him several years ago. He bought his daughter a PT Cruiser when she was still in high school. And I said, hey Dennis, so you got your daughter a PT Cruiser? He goes, yep. I says, well, let me know when it overheats and I'll tell you what you need to do to fix it. So he just filed that away, I guess, and him and his father-in-law are working on it in the driveway with the hood up about 2 years later. And I hollered over there. I said, Dennis, what's going on with that car? He says, it's overheating. I predicted it was going to do that. And I says, replace the radiator fan, and put fresh coolant in it and a thermostat and see what that does. And so he called me later and he said, that took care of the whole problem. I sure appreciate it, because they were trying to figure out what it was on one of these dadgum things. That's not a good strategy on every car, but that's usually what's wrong with these. I've seen the fan motor crap out on them and the radiator clog up, and and you can drive yourself nuts. You just go ahead and do those things to start with, because think about the stuff that can wear out. The radiator can get clogged up, the fan can wear out, and the thermostat, doesn't cost much to pop one of those in there. Anyway, but we had a transmission swap underway on this one, and we'd need to check it for an overheating problem. So anyway, that's what was going on the PT Cruiser. This was a little car we worked on a fair amount because it belonged to one of the other instructors. We also had to troubleshoot a Nissan. Well, I said there were 2 jobs, actually 3. This 2007 Nissan Altima had a delayed reaction blower motor. She'd get in the vehicle, she'd turn on the blower, crank it up. The blower wouldn't work for 5 minutes, and then it would kick in and start working. Well, we duplicated it and did some voltage checks in the fuses, and after we transposed the potted blower and defog relays, in other words, we took a defog relay, was the same relay, cost about $35 for one of these, and popped it into place where the fan problem was away. The guy that did this job, that we all figured it out together, went to work at a Nissan dealer, and he says he found a couple of these doing this exact same thing, and he instantly knew what to do to fix them, and really impressed the service manager at the Nissan dealer. But anyway, that was a fairly simple but interesting job. Incidentally, those potted relays are a different kind of relay. They got some solid state components in there. They do the same job, but they fail in different ways than a conventional relay, like this black one you see right here. See, this black one's just got a coil and a little clamping resistor in it and all that kind of stuff. But this one here works different, and there's a lot of these cars that are running these potted relays, Asian cars particularly. But things are, have been changing for years, and that, so the customer said go for it. So said opted for the used LKQ power plant, and the real adventure started. And Willie's a Vietnam veteran that was in my program. He's a little bit older than me, and he just got in there so he kind of learned how to do the work, And he was probably one of the most dependable, solid guys that I had when it came to doing something, because he was tough and he didn't quit until the job was done. And that's the kind of guy you want working for you. When I was teaching for all those years, it seemed to me like the Lord always blessed me with 1 or 2 students that were really solid, that would do really good live work, because I basically ran the place like a garage, and that's where they get their best learning. You can't teach on trainer cars and expect the students to get really good at doing the actual work. because they don't take trainer car stuff seriously at all. But when they're working on somebody's car that they're going to have to drive for some reason, it puts them in a different frame of mind and they do better work. Okay, so now when we got the engine in, the old engine had 6 flywheel bolts. The new engine had 8 flywheel bolts. Well, that's crazy. So what in the world here? So I called him up. I said, what the deal is? Are you giving me the wrong engine or what? And he said, no, it doesn't have anything to do with whether it's Windsor or Romeo. Some of those engines have 8 flywheel bolts and some have 6. And apparently it's got to do with the vendor that produced the crankshaft or something, you know, because they'll change sometimes in mid-model year and all that. But they said there was no way that you would know that whether you had 6 or 8 flywheel bolt holes until you got your eyes on the flywheel. I mean, that's just all there was to it. And so anyway, because our old engine had 6 and the replacement engine had 8, we had to buy a flywheel. So we bought a flywheel for 30 bucks, I guess a used one, and we put it in there. And so the replacement engine was in place, got everything hooked up. It was spinning over with almost no compression on any cylinder, and it was intermittently backfiring through the intake. What in the Sam Hill is this all about? And so that was a dirty hand that was dealt. There was no way you could tell this was going to happen until you got that engine in that vehicle. Think about that. You know, and the salvage yard is not going to pay you any labor. I mean, if this was a student, he didn't mind doing the job twice, but in a shop, boy, you got some issues there. And if you're the shop owner, the mechanic didn't do anything wrong. He got the engine in good faith, put it in there, and, you know, so this was bad. This was one of those revolting developments that makes nobody happy, because now the customer's going to have to wait longer for their vehicle because the first engine we got was no good, even though we had it in there just like it was supposed to be. Everything was done right. Good salvage parts companies will start the used engines they're planning to sell while the engine is still in the vehicle. That's just a standard procedure. The local salvage yard company, where I took this picture you see in the background, what they did for years, I don't know if they still do this, is they would start the engine and then they would squirt, whenever they got it ready to put it on the shelf, they'd pull the spark plugs and they'd squirt some automatic transmission fluid in every cylinder. And then they put the plugs back in and they would set it on the bench in a warehouse. And so that they would know the engine was good, and they'd know that it hadn't been sitting there so long that it was going to be rusted and locked up or whatever, even if there was a lot of humidity. And so if these people started the engine, it probably what happened was somebody had turned the engine backwards while they were disconnecting the torque converter. We only had 99 psi on one cylinder and 40 to 60 on all the others. Adding oil to the cylinders didn't need to do anything, because you add oil to them, it tells you if it rings or whatever. So apparently they got this thing bad out of time by turning it backwards when they were disconnecting the torque converter. That was what I figured out must have happened. And so I spoke to LKQ warranty agents. You know, they always want to know what makes you think the engine's bad, and you got to give them all kinds of information and tell them how you tested it and all that. But they sent us another engine, and so Willie, he popped that thing in there about a third of the time that it took him first time around, because after you've done it once and you're having to turn around and do the same job again, that you get faster. Everybody knows that. That's what makes commission mechanics make good money, is because they've done the same work over and over and over again, and they can do it in a fraction of the time that it takes somebody that hadn't ever done it before. So anyway, we settled that thing into place, and it took care of it. You know, we got a whole nice running truck out of the deal. Well, here's a little set of check boxes I put together for my students. You're going to earn what you get paid in this business. That's just all there is to it. Not every repair is going to go the way you want it to. Some of them blow up in your face. Always take responsibility whenever you make a mistake. Don't try to act like it's somebody else's fault. Just be honest. Share your knowledge freely. Some people will try to hold on to their knowledge because they make them feel like they're more valuable or they know more than everybody else. But the more you share, the smarter you'll get, because every time you share your knowledge, it makes you understand better, believe it or not. And I learned that as a teacher, that I got to where I understood things better and better and better the more I taught, because you have to process that information and put it out to other people in words and then answer their questions and explain things. Show up to work early, don't leave early, get a lot of work done, ignore the whiners in the other service bays and do your job. Try to make it a better place for everybody else there. Don't lie, and don't steal. I don't know it, the people I've seen that were stealing out of customers' cars, if it was nothing but a little bit of change off of the console or out of a, whatever, they would actually set a trap for them, put a vehicle in there nobody had touched but them, and then when they looked at it, when the guy got through with it, they'd find some of the money missing that they had put in there for him to take. And then I've seen people with families that stole money like that and got fired for stealing money out of cars. But they'd always make sure they knew it wasn't a hearsay thing, Well, I appreciate you guys coming around and listening to my videos. Put a like, share it with your friends, and let's be careful out there, and I hope you have a great week.